Today I'm going to talk to you about some trigonometric identities, and the first one I'm going to start with is the tangent. So within this I'm going to actually just draw the unit circle, and I'm going to pick a coordinate on that unit circle, and of course this is its radius. So if I look at this coordinate, it's got an x coordinate and it has a y coordinate. Now if we think about this, this forms a nice right angled triangle, and I'm going to apply right angled trigonometry to this. So let's have a look. In our right angle trigonometry, this is the hypotenuse. Let's, for argument's sake, put the angle from the positive x-axis. We've got this as our opposite and this as our adjacent. Now, looking at this, let's look at the sine ratio. Well, sine ratio, sine theta equals opposite over hypotenuse. Well, the opposite is the y coordinate, and the hypotenuse is just 1 because it's a unit circle, isn't it? So it's y over 1, so therefore sine theta equals y. Let's look at cos theta. Well, cos theta is the adjacent to the angle, which of course is our x coordinate, divided by the hypotenuse, which is just 1. So of course it's x over 1, so that means the cos ratio is just the x coordinate. Next, I'm going to look at tan. Well, tan theta is opposite over adjacent. Well, the opposite, as we've just learnt, is actually the y coordinate, and the adjacent, as we've just learnt, is the x coordinate, so it's y over x. Now, if I look at what y actually is, y is sine theta, and x is cos theta. So we can say that that should be theta, not x, that the identity tan theta tan theta equals sine theta over cos theta is true. Okay, so basically an identity is a relationship that holds true for all legitimate values of a pronumeral, in this case any angle, this one. Now the next one I'm going to look at is the Pythagorean identity, and I'm going to use the same triangle. I'm just going to now put on there that we've got y and we've got, this is x, okay? And what I'm going to do is apply Pythagoras. I'm going to apply Pythagoras to this. So we know that Pythagoras is a squared plus b squared equals c squared. Well, if I put a, b and c onto this triangle here, my a is x, my b is y, and my c is the hypotenuse. So I get x squared plus y squared equals 1 squared, because at the moment the hypotenuse is 1 because it's the unit circle. Now I've just established that x is equal to cos theta and y is equal to sine theta. So I can place those in for substitution. You get cos squared theta. By the way, I'm just going to tell you that when we square a trig identity, we usually put the squared there. It's equivalent to saying cos theta all squared, but it's just the way we write it. And this one is sine squared theta equals 1. Now, although usually when you see this identity, it's actually written the other way around. We usually say sine squared plus cos squared, sine squared theta plus cos squared theta equals 1. That's the Pythagorean identity. So this is another important identity that we'll use to calculate some values. I'm going to show you with some examples. I'll clear some space how we might use these two identities to do a question. Alright, so in this particular example I've been told that sine theta equals positive 0.4, and I'm looking at the domain between 0 and 90 degrees for theta. Now that makes sense because this is the first quadrant of the unit circle, and of course sine is positive in that quadrant. Now all I've got to do is use this fact to find cos theta and tan theta. So what I'm going to do is I'm going to substitute the information I know into the Pythagorean identity to help me. So sine squared theta plus cos squared theta equals 1. That's our Pythagorean identity. Substitute this in. Well, sine theta is 0.4, so I need to square that to give me sine squared theta, plus cos squared theta equals 1. I'm going to rearrange this because essentially I want to find cos theta, so I'll make cos squared theta the subject. So cos squared theta equals 1, take away 0.4 squared. Now I need to work that out, but 0.4 squared is 0.16, so cos squared theta is 0.84. I subtract that. And then to find cos theta, I just simply square root 0.84. So cos theta, and of course when you square root, you get positive and a negative answer. So square rooting that, I'd have to use my calculator for that, gives me 0.917. That's correct to 3 decimal places. Now, I've got to look in the first quadrant, and the first quadrant is where cos is positive. So the actual solution for this domain is that cos theta equals, I think I might be off the bottom of the screen there, apologies. Where can I write it? I'll have to just go cos, well, it should tell you cos theta equals the positive version of 0.917. All right, let's go on to look at tan theta. What I can do is I can use the positive numbers for this, because obviously I'm looking in the domain and tan is positive in that. And I can also use the domain, the identity, apologies, of sine theta over cos theta equals tan theta. And substitute those values in. So sine theta is 0.4, cos theta is 0.917, and that will give me the value of tan theta. I'm working that one out on the calculator, I get 0.436. Okay, and again that makes sense because it's positive, and of course tan is positive in the first quadrant. And that's pretty much everything you need to know about identities. Just be aware there are many trigonometric identities. In fact, we only use these 2 in the maths method syllabus, but there are way more, and you could be asked to use another identity.